and we can check our work. X times x is x squared. Bingo. X times negative 1 is negative 1x. Negative 3 times x is negative 3x, so I combine the negative 1x and the negative 3x, that gives me negative 4x. And negative 3 times negative 1 is positive 3. So I have exactly what I wanted. I can now say that x squared minus 4x plus 3 is just the same as saying x minus 1 times x minus 3. So using this representation here, what is the other root of my polynomial? What is that other root going to be? I know that one of them was positive 1, and now I know that x equals positive 3 will be another root because that will make the other factor 0. And so I found both roots. Now this is a complicated process that is just nothing more than applying our knowledge of regular division and normal factors. It will take a little while to get used to, but we're going to try one more example and we should start to get the hang of it. Alright, so here's another example. Given the polynomial function f of x, which is x cubed minus 2x squared minus 5x plus 6, you are told that f of x has a root at x equals 1. Find the other roots. So the first thing to note is how many other roots should there be? Hopefully you said 2 because this is a third degree polynomial, so it should have how many factors? 3 of them. Now, which factor do you know? So if I were to write f of x as x cubed minus 2x squared minus 5x plus 6, you would know that there are going to be 3 factors. Okay, what's one of the factors going to be? Well, since you have a root at 1, you know one of the factors will be x minus 1. All right, so now we want to think about how can I find the other roots? Well, what will tell me the other roots? The factors, right? Knowing these factors will be able to tell me, okay, what is that other root? What are those other roots going to be? All right, so how can we solve for those other roots? Well, hopefully you're going to apply that same idea that we had before, which is if we divide by the factor we already know, x minus 1, on both sides, and we're going to end up with solving for these other roots. Now, you might be noticing, you might be saying to yourself, well, I need 2 more roots. How many roots is this going to give me? Well, let's just hold off for a second and we'll see what happens. So, let's go ahead and divide x cubed minus 2x squared minus 5x plus 6. At this point, I want you to go ahead and try the division by yourself. If you get stuck, think about what you're doing. You're trying to figure out what you can multiply x minus 1 by so that you get x cubed minus 2x squared minus 5x plus 6, and that should help carry you through. And when you're finished, go ahead and press play again. All right, so we're going to move through this a little more quickly. Remember, I'm looking for what I can multiply x minus 1 by to get my bigger polynomial. And so notice that whatever it is, the first 2 terms, so the first term will be multiplied by this big term, and what do I want it to give me? Well, I want it to give me x cubed. So that first term should be what? What will I multiply x by to get x cubed? It will be exactly x squared. And notice how I line it up with the squared term above, right? I want to keep my place value in order. So now I realize, okay, when I multiply this first term by this whole term here, I'll get the x cubed, but I will also get negative 1x squared. And so what I want to do is I want to take that piece out, what I get when I multiply those two. I want to subtract it away from my bigger polynomial. Whatever I have left needs to come from multiplying other terms by x minus 1. So x squared times x will be x cubed, and then x squared minus 1 times minus 1 will be negative 1x squared. And I want to subtract that away. So doing that, I'm subtracting the whole piece, so I'll be distributing the negative in, so that'll make this a negative and this a positive, and that will end up giving me, these will cancel, and I'll end up with negative 2x squared plus 1x squared, which will be negative x squared minus 5x plus 6. Right, because I have nothing else here to subtract from the x term or the just constant term, so those will just stay the same. So now I've got to figure out, okay, what can I multiply x minus 1 by to get as much of this as possible? Well, I know I need to get a negative x squared term, so what could I multiply? Remember, whatever's here, I'll multiply by everything in this term, and I want it to give me a negative x squared term. Well, I'm going to have to multiply x by negative x in order to get negative x squared. So when I multiply the two together, I'm going to get negative x squared. I multiply negative x by negative 1, which will give me positive x. And now that's what I get from multiplying this term by this whole factor here. And I want to take away whatever that gives me from what I need, so that all I'm left with is the last piece that I need. And so these will cancel. Let me actually show that. I'm subtracting here. So this will become positive, and this will become negative. And I'll be left with negative 6x plus 6. And so now that's all I need left. I'm going to multiply this last piece of my answer by x minus 1, and that's going to give me, hopefully, what I need. So what times x will give me negative 6x? It'll be negative 6. Negative 6 times x is negative 6x, and negative 6 times negative 1 is positive 6. And so all I've got left over when I subtract these away, remember the signs will change, so this will become a positive and this will become a negative. These will cancel and these will cancel, and I'm left with nothing. Meaning the remainder of my division is 0, which is a good thing, right? Because we had a factor. X minus 1 is a factor, so it should go in evenly to my bigger polynomial. And the question is, what did I find out? What does this polynomial do? I want you to pause for a second and think about that. This polynomial is the polynomial that when I multiply by x minus 1, right? Think about it. It kind of goes right here. And when I multiply by x minus 1, I will get this bigger polynomial. But you might be saying to yourself, well, I need two factors. Why did I end up with x squared minus x minus 6? What kind of a polynomial is this? It's a second degree, so how many factors does it have? It has exactly 2, right? And since it has 2 factors, I know that it will have also how many roots? It will have 2 roots, right? So let's just see where we're at right now. We'll kind of bring this down here for a second. We've got f of x is equal to, we have the first factor, gives us the first root, and what do we need to multiply x minus 1 by to get x cubed, that x cubed polynomial? We have to multiply by x squared minus x minus 6. Okay? And so we know from our division that when we multiply these two things together, this is the same as our original polynomial. And each of these is a factor, right? Now this isn't a linear factor, it's a quadratic factor. So how many roots will this factor have, right? It will have 2, and that's important to remember because from this linear factor we get 1 root, right? We know that to make this 0, we plug in positive 1. Well, here's the question. What values of x will make this 0? What are our options here? I want you to pause for a second and think about what we could do. There are a couple things. The first thing that we could do is we could factor this into its two factors. And you may remember from factoring, right? I want to know what I can multiply together to get -6 and add to get -1. Well, that shouldn't be too hard, right? You know that that would be x minus 3 times x plus 2, right? Simple factoring. And that is one way that you could find your additional factors, right? You could simply factor it really easily. But let's say that you didn't want to factor. How else could you find the values that will make this 0? Because remember, how many values will make it 0? 2 of them, right? You're asking yourself the question, what is x squared minus x minus 6? When will that equal 0? And I encourage you to go ahead and pause the video and try this on your own. What will happen if you solve this here? Okay? What will happen if you solve this? And you should find that when you solve this, you're going to get 2 roots. What are the roots that you get? Well, they should correspond to the factors we found, right? So you're going to end up with roots that are at 3 and -2, which tells you exactly what you wanted, right? If one of the roots is at 3, then one of the factors must be x minus 3. And if one of the roots is at -2, then one of the factors must be x plus 2. And so now you have all the factors. What are those factors? Well, this is x minus 1, x minus 3, x plus 2. So what are the roots? The roots are x equals 1. We knew that already. X equals 3, and x equals -2. And so those are the other roots of our polynomial. All right, at this point, we kind of want to stop. We've talked about a lot, and we want to sort of go over what is the big key point that we've learned. We're taking the knowledge we have that if we have a third-degree polynomial, we can write it in terms of 3 factors. And if we know one of the factors, we can divide by that factor to help us find another factor. Okay? And when we divide, all we're doing is the same division algorithm we've always been doing. We say how many times will x go into this first term, right? In other words, what term can I multiply x by so that I get x cubed, which is just x squared. X squared times x will give me x cubed, but remember, because I'm using the distributive property when I multiply these back, I have to consider what happens when I multiply x squared by both pieces of my term. I want to take those pieces away. What do I have left? Because whatever I have left is what I'm going to need to get when I multiply the other 2 terms by x minus 1. So once I subtract that away, I'm left with this piece here, and I ask myself, okay, what do I need to multiply x minus 1 by so that I can get as much of this as possible? Well, the piece I'd like to definitely get is this negative x squared piece. I definitely want to have, when I multiply this, whatever this is, by x minus 1, I need to get a negative x squared. So I think about how many times will x go into negative x squared, or in other words, what times x will give me negative x squared, which is just going to be negative x. And so that's my next term. Then I say, okay, what happens when I multiply negative x by both pieces here? Because I want to get rid of that. I don't need that anymore. Whatever I have left is the last piece I need. So I go ahead and I say, okay, negative x times x is negative x squared. Negative x times negative 1 is positive x, and then I subtract that away, and what I'm left with is negative 6x plus 6. That's what else I need from my last multiplication to get me all the way to x cubed minus 2x squared minus 5x plus 6. And so I will ask myself, okay, what times x will give me negative 6x? And that is exactly negative 6. I multiply out, I get negative 6x plus 6, and when I subtract, these will all cancel. And so you get a remainder of 0. And it's important to remember that is what you're looking for. If you don't get a remainder of 0, why is that a problem? Well, it's a problem because this is a factor. X minus